Welcome to Course 18 of Course 2 in Saxon Math. Today you're going to learn about polygons and similar and congruent shapes. We're going to name a polygon by the number of its sides. We're going to identify a polygon by naming the letters of its vertices. We're going to identify regular and irregular polygons. And we're going to identify similar and congruent figures by comparing their corresponding parts. For vocabulary, we have the first term we have is congruent, which means the same shape and size. Corresponding parts means the angle from two polygons that we are comparing. So if we were talking about the corresponding parts of our hands, we might talk about the back side of our hands. So if I was talking about my right hand and I said, what corresponds to the back side of my right hand on my left hand, you would say the back side. The back sides, or the tops of my hands, correspond with each other. Polygon, when three or more lines are connected to enclose a portion of a plane, not three-dimensional, but a plane, for example, a triangle or a hexagon or an octagon. Then a regular polygon, if all the sides have the same length and same angle, they're regular. If they don't, then they're considered irregular. And then similar shapes are the same shape, but they might be of different sizes. Some bigger than the others, but they're all the same shaped triangle. So let's look at our polygons and our sides. So you start with a triangle. It has three sides. Quadrilateral has 4, pentagon 5, hexagon 6, and heptagon 7. And you can see here on the list. When you get up to 15, then it just becomes a 15-gon, a 16-gon, a 17-gon. The point where two sides of a polygon meet is called a vertex. A particular polygon may be identified by naming the letters of its vertices in order. Any letter may be first. The rest of the letters can be named clockwise or counterclockwise. The polygon below has 8 names as shown. So you could describe this polygon as this USTV going clockwise, USTV. Or you could do it counterclockwise, UVTS, UVTS. Just so you can name them just so that you keep them in order, either clockwise or counterclockwise. Each one of these are vertexes. All of them, plurally, are called vertices. So regular and irregular polygons. So here's an example. Remember what the definition of regular polygon is. A regular polygon, all of the sides have the same shape. Notice that these all are the same length. Where this irregular one, this one here, is shorter than these other two. So it's irregular. So looking down here at our example, name that polygon. What kind of polygon is that? Well, if you look up here at our chart, you can see if you count your sides, you have 1, 2, 3, 4, 5 sides. So we know that A would be a pentagon. Now, is this pentagon regular or irregular? Are all of the sides equal length, or some sides longer than others? If it's longer than others, it's irregular. If it's all the same, then we'd call it regular. What do you think? Pause, state your answer, and then continue the video. Okay, it's irregular because you have these two down here that are longer. And again, we already talked about it being a polygon that is a pentagon because it has 5 sides. Which of these figures is not a polygon? Or which of these is a polygon? Remember our definitions. One definition is that the sides, it has to be closed in. Another one is that the sides need to be made up of segments. And the other definition is that the sides, or that it needs to be on one plane. So with that in mind, pause this. See if you can figure out which of these, A, B, C, and D, are polygons and which are not. You should have came up with only C being a polygon. A is not because it has this curved line, which is not a segment. B is not because it's not closed in. It's missing this side right here. And D is not because it is three-dimensional. It's not a single plane. Although, just this front face right here, that would be a polygon. But so would this be a polygon. And so would this one up here be. So this is really made up of a bunch of polygons. But itself is a three-dimensional cube. It's not a polygon, even though its faces are polygons. When figures are similar, they have the same shape even though they may be different sizes. When they're congruent, they're the exact same shape. So when you look here at this first set right here, these three that I've marked in yellow are similar because they're the same shaped triangle, but they're different shapes. This one's smaller, this one's bigger, but they're all the same shape. They're all regular triangles. They all have equal sides, where this one does not. So this one is not, number 4 is not similar to these three. But all three of these are similar because they're the same shape but different sizes. Come down here, and although these two are also similar, they are similar also because they're the same shape, they're also congruent because they're the exact same size. Where this one is not congruent because it's larger than these two. So if I was to ask about these two, you would tell me they are both similar and congruent. These three up here are only similar. They are not congruent. They are not the same size. So here in A, which of these 4 quadrilaterals appear to be similar? Meaning that they're the same size but not necessarily the same shape. And which of these quadrilaterals appear to be congruent? Well, for A, you should have said that 1, 2, and 3 are similar. And for B, 1 and, I'm sorry, this is 4. 1 and 4 are similar, or congruent. 1 and 4 are exact same size, so they are congruent. They're also similar because they're the same shape. But this one here also fits in with these three as being similar. But 2 is not congruent because it's not the same shape. Well, it is the same shape. It's not the same size as 1 and 4. In order to be congruent, like 1 and 4 are, you have to be the exact same size. So now let's talk about corresponding. Remember how I was talking about the back of my hand? Look at number A, looking at angles in X, Y, Z. Which angle in X, Y, Z corresponds to A in A, B, and C? So which angle in X, Y, Z compared to in A, B, C? Which one corresponds to this angle right here? Which one of these over here is the exact same corner of this triangle as A is? That's what it's asking you. And then on B, it's asking you about what side corresponds. Rather than a vertice like A, it's asking you for a side like ZY or CB. See if you can do it on your own. And then start the video. For our first answer, the corresponding vertice in both of these is X and A. If we rotate this over, that X is going to land right where that A is. And then for B, the sides that are the same is YZ. This side here is the same size, corresponding side with B and C right here. They correspond. These are the sides that are the same in both triangles. These are the vertices that are the same in both of these triangles. That's called corresponding. They correspond with each other. Your written practice for tonight, your tickets in the door, is 3, 8A, B, C, and 27A, B, and C. You need to submit your answers to me online for those problems there. And then if you have any questions, bring them to class tomorrow and we'll review them together with everybody. Thank you for watching this video.